Welcome to part two of our three-part series on Turfgrass 101, a three-part primer for turfgrass professionals. I'm Mark Schneider, a technical sales rep with the Nutrite Group, and I'll walk you through some of the aspects that we need for proper turf management. One of the things we talk about at great length is the 360 degrees of managing turf. And you can see by Dr. Madison's quote from 1971, fertilizer is the #1 management tool. It's worth all the attention you can give it. A little bit about Liebig's Law. This is something that most turf professionals will encounter at some point or another in any of their soils courses. And Liebig's Law really describes how much can be taken up by the plant of the various elements within a soil. So if you look at this barrel on the left and think about the various staves in the barrel, the lowest stave is obviously going to limit the amount of water that's held in the barrel by the other staves themselves. So if each stave represents a different element, the lowest element is going to really limit the other element's ability to be taken up by the plant. We're going to talk a little bit about nutrition, the macro elements, of course, in order: hydrogen, carbon, nitrogen, oxygen, magnesium, phosphorus, sulfur, potassium, and calcium. Then we'll talk a little bit about minor elements: boron, copper, zinc, iron, manganese, molybdenum. We need 17 in total to grow any type of turf grass plant. And it's really based on the needs of the plant and what we found in the soil itself. Growth and field usage really determine what our seasonal goals for fertilizer are going to be. And it's based on soil and or tissue testing, something that we do a considerable amount of as turf professionals. When, where, and how much product to be used, and some of the factors that influence this decision include the season, soil temperatures, usage, and species. Soil testing is a critical amount to determine the needs of the plant. This is something that our group really stresses. It identifies nutritional strengths and weaknesses and can eliminate costly applications. Here's an example of the typical soil test that you get back from the lab. On the top, you'll see the pH value, the buffer pH, organic matter, which we talked about in our previous section. In this case, it's 2.2% of the total, and the ideal range being 1.5 to 3%. So this sample really falls in a good section of organic matter. The phosphorus expressed in parts per million. In this case, we have 17 ppm, a little bit on the low side when the recommendation would be between 20 and 35 ppm. Potassium, calcium, magnesium, and other elements are expressed down the chart here. Really what we're looking for in soil tests for turfgrass are really the top 10 or so of these elements. Some of the minor elements can be lacking as well and have a great influence on turfgrass performance. Let's talk a little bit now about nitrogen. As it says there, it's essential for plant growth. It's really the sort of the gas pedal of the plant. It has a great influence on color, stand density, chlorophyll formation, and it's required in the highest quantity of all the elements that are available to the plant. Turf nitrogen, this is a slide given to us by Dr. Byron Vaughn, a PhD that we work with out of Virginia. And cool season turf, for those of us in the Northeast, requires about 4 pounds per 1,000 square feet per year, with adjustments as follow. If you've got a new turf stand, add about 1 pound of N for the first year. If you have low organic matter and or sandy soil, add another pound of N. If you've had a wet year or irrigation, add 1 pound of N. If your clippings are returned to the surface, you can reduce your seasonal total by 1 pound. And if it's an older turf, you can reduce it again by 1 pound. Slow release fertilizer is being used, reduce it again by 1 pound. But really never exceed 6 pounds of N per 1,000 per season, or apply less than 3 pounds of N for most home lawn, sports fields, and golf applications. Here's a couple of examples, and we've seen them all. The N deficient area on the left slide, and then the area where it has been fertilized on the right. And the slide on the right is something that we probably see every spring, where someone has gone out and applied fertilizer to an area without calibrating the spreader or its swath width. So this would show up a few weeks later. We're talking now about phosphorus. As it says, it's essential for new roots and shoots and initiates seedling growth, plant vigor, and we really have to use a soil test to determine the need. You can see where the deficiency was. This was an area on a golf course where they laid out a piece of plywood, fertilized with the phosphorus product, and then several weeks later, the unfertilized area looked like that, sort of that purplish color that shows a phosphorus deficiency. Potassium, the third element on a typical bag of fertilizer, is really important because it improves stress or winter hardiness, drought stress, wear tolerance, and disease resistance. It's the highest concentration of K, is second to N in the leaves, and tissue K quickly leaches out of any clippings that might be left on the turf sward. The minor elements, as I mentioned, really, if we look at the chart on the left, we call this our torpedo chart. And really what it describes here is if we start at the low range of acidity for a low pH of 4 and move up towards a range of 10, by looking at the various elements here and their importance, we can really see how pH influences soil or uptake of these elements. Nitrogen, phosphorus. As we get down into things like iron, the higher your pH, the less iron is available to the plant. It's also an essential element needed. Manganese can be limited by a higher pH. Here in the Northeast, we're really dealing with pH ranges between 5.5 and 8.5 in some cases. But in summary, what I'd like to say is that you can have very good looking turf at both ends of that spectrum, but you really have to be cautious of the minor elements that are lacking in your soil profile and make adjustments as needed. The other next three elements that we want to talk about, the other three macro elements, of course, are calcium, which is important for cell division and membrane function. Deficiencies result in poor root and shoot growth. Sulfur is present in certain amino acids, proteins, membranes, and coenzymes. Deficiencies result in chlorosis. Magnesium, an important component for chlorophyll, it activates many enzymes. Deficiencies result in foliar chlorosis. Factors involved with fertilizer release. I mentioned in the other section about the influence of soil and air temperature on turf grass growth. It also has a great influence on fertilizer performance. Water availability is another one that can help control fertilizer release. Microbial activity is very critical for the breaking down of the various fertilizer products that you might be using. Coating thickness and the type of coating is important, along with enzyme activity in the soil itself. So we're going to talk about the factors involved with enhanced efficiency fertilizer release. If you start with the particle on the left, which is a typical particle of urea with a polymer or other type of coating, and the N is actually, the water actually, or N dissolves into the solution, into the granule. The N moves out through the coating and into the plant and released into the soil. Here's an example of 4 different products with varying degrees of slow release content. The 32-210 on the top has 90% slow release content. The 2515 has a 75% slow release content available for 16 weeks. The 24010 has 50% slow release content available for 10 weeks. And the 25515 has 65% slow release and is available for 8 weeks. Now we're going to talk about getting the best value or the cost per season out of the products that you're using. We'll talk a bit about enhanced efficiency fertilizers requiring fewer applications per season. What it really gives you is no peaks and valleys of release, color, or growth. And it really allows a lawn care operator to upsell other services, overseeding, aerating, weed and insect control, plus other cosmetic practices. And really the value of enhanced efficiencies fertilizers are their longevity options. 2 to 6 months in some cases, you're able to vary your application rate and the frequency of application. You're really getting more N into the plant, it really does limit the loss to the environment, and you're getting more value for your investment in the product you purchase. So really, the most important thing that we want to talk about at this point is really what's in the bag. If we look at any typical bag of fertilizer, the three numbers that you see in the front represent nitrogen, phosphorus, and potassium. We're going to talk a little bit about the cost comparison about two different products. The product on the left is a 32210 with 90% slow-release Nutrient. And really, by the various bars there, you can see that it's composed of a Nutrient 45-day release, 90-day release, a 120-day release, and a 180-day release in various blends. And the urea and diammonium phosphate as well is in the bag. The blue bar at the top really represents the small amount of filler that's needed in a 90% slow-release product. The product on the right, a 20-2-10 with 60% SCU, initially you'll see the blue bar is a lot more filler with the other slow-release content of the SCU in there as well with the darker green. So much less slow-release content in a 60% concentration analysis. So we're going to talk about finding value in your fertilizer blends. Really, what are the ingredients? What is the cost per bag, the cost per acre to apply? And really the final point, and the most important one, is the cost per day of greening. An important decision when you're purchasing different fertilizer blends. So we're talking about how do you build the analysis? Well, this is an interesting exercise. If we look at these three different products as listed here, we have a 1608, a 24012, and a 32016. And the legend shows, of course, how much urea, how much XCU, and how much potash is in each one. There's varying price points for each one of these different blends, which I'll go through here in a minute. And it'll really demonstrate to you how to get a better value for the money that you're spending for a given area. The product here on the left, the 1608, really has 990 pounds of filler in it, where 500 in the other one, and the more all-mineral blend of the 32016 has no filler in it at all. Interestingly enough, each one of these is a 2-to-1 nitrogen to potash ratio, 16-8, 24-12, and 32-16. So really, that 2-to-1 ratio is maintained across the various blends. So how are we building the blend? Well, if we look again, starting at the top, the 1608, in this case is 50% XCU, 0.5% iron, 24010, same thing, 50% XCU, 32016, 50% XCU. Here's the bag cost at first glance, 2192, 2601, and 30.33. A lot of people, because we're consumers, would say, well, I'm going to take this $21 bag. You need 6.3 pounds per thousand to apply 1 pound of nitrogen. As you move across the spectrum here, to apply 1 pound of N with this product, you need 4.2, so lesser than the 6.3. And if you go over to the far right here, 3.1 pounds, or almost or less than half of this blend here. This 50-pound bag will cover 7,900 square feet at a cost of $277 per thousand. If we were to fertilize 100 acres, we would need 549 bags of the product costing $12,000. If we look at the next one along the chart here, we only need 4.2 pounds per thousand. A 50-pound bag will cover 11,900, 219, less than 277 for 100 acres. We'd need fewer bags because of the higher analysis of N. We'd need 366 bags for a cost of $95.19. If we go to our highest analysis blend, same thing, 50% slow release, 0.5% iron, $30 bag. You're going to need far less product per thousand, 3.1 pounds. A 50-pound bag will cover 16,000 square feet at a cost of $1.89 per thousand. If we were to do 100 acres at this rate, we'd only need 271 bags for a cost of $8,200. So really, if you go back to the top and you look at the price per bag, really, when you look at what you're covering because of the higher analysis, to apply a pound of N, the higher cost product will cost you less at the end of the day. Something that's very important to consider when you're making your fertilizer purchases. What are the drawbacks of some of the low analysis fertilizers? Well, yes, they may be less expensive per bag, but the filler costs money. Little to no agronomic value in the filler itself. It does not improve nutrient distribution, and also you're handling more bags and handling the freight, the time, the spreading, the environmental footprint, wear and tear to your staff and your equipment can be quite high because you're obviously handling more product. The higher analysis fertilizers, on the other hand, may cost a little bit more, but the more nutrients per pound of fertilizer. Fewer bags, less freight, handling, spreading, lower cost nutrient per 1,000 square feet. So now we're going to talk a little bit about enhanced efficiency, EEFs as we refer to them. Really, what are they? Well, they're fertilizer products with characteristics that allow increased plant uptake and reduce potential of nutrient losses to the environment. Gaseous losses, leaching or runoff when compared to an appropriate reference product, in this case, urea. The urea prill coated with the polymer coating, the N is dissolved into solution in the granular and then is pulled out through osmosis out of the plant into the root system. Now, when we use the enhanced efficiency products, the fewer fertilizer apps really help us to reduce overall fertilizer expenses and equipment costs. It allows you to optimize your labor allocation. You can visit more properties per day, offer additional revenue generating services, overseeding, aeration, and weed control, and less bag handling reduces your risks of injuries to you and your staff. Let's look at comparison of the enhanced efficiencies and the SCU technology. On the left, you have your EEF, or a polymer-coated prill released by microbial activity, moisture, and temperature. And as I showed on the previous chart, anywhere from a 5 to a 32-week release period. The SCU, which is an old standard we've been using for decades, is a sulfur-coated prill. It again is also released by microbial breakdown and weathering. But the big drawback here is a sudden loss if this prill is damaged, and typically a 4 to 6 week release in comparison to the 5 to 32. So if this coating of sulfur is chipped at all, the urea inside will release immediately, and that may or may not be what you want. That brings us to the end of part 2. We'll be along with part 3 here shortly. Thank you.